Alright, hey guys, today we are going to do some more comparing expressions using tiles and our comparing expressions mat, and we are going to learn our third legal move. So let's start with a quick little warm-up. So I have two mats here, and I want to compare, see which side has a bigger amount. So why don't you guys pause the video and try this one. Alright, so you should have tried it already. So the first thing I always look for is zero pairs. So here I see a zero pair. I can remove that because those make zero together. On this side I see a zero pair, a couple ones. Over here I see a zero pair. Here's another zero pair, kind of a lot of zero pairs. This X and negative X tile, that makes a zero pair. So those are all gone. So that was my first legal move I learned yesterday. The second legal move is think of a balance. Remember, when you have a scale, as long as you take away the same amount from both sides, it's okay. So I see there's two negative tiles on this side. I can remove that as long as I do the exact same thing to the other side. So I can remove those as well. Remember, it still keeps it balanced because I took away the same thing. Okay, so those are both gone. So now let's see what I have left. On mat A, I have 4 1 tiles. On mat B, I have nothing or 0. So mat A has the bigger amount, so mat A is bigger than mat B. Alright, our next problem, we have mat A and mat B, and we want to see which side is bigger. So I'm going to start by making some zero pairs. Zero pair, zero pair. My next legal move, I'm going to remove the same thing from both sides. So I see an X tile on both sides. That's worth the same. I don't need to worry about that. I also see a 1 tile on both sides. I can get rid of that. So let's write what we have left. On mat A, I see I have 3 X's. On mat B, I have 1, 2, 3, 4, 5, 6. Okay. All right, so now I'm going to answer the questions below. Now I'm going to start, actually I'm going to kind of go in reverse, and I'm going to start by asking what value of X would make these sides equal. So basically, what could X be that would make this side and this side both equal 6, because that's what I have over here. Well, think if I plugged in 3 times something is 6, well, that would have to be a 2. So if X was 2, let's see if that works. That would be a 2, a 2, and a 2. 2, 4, 6, that would be equal. So if X was 2, they would both be equal. Okay, what if I wanted to know, let's go back to question A, what values of X would make side A greater? Well, if X was worth a 3, that would be 3, 6, 9, that's bigger than 6. If X was a 4, that would work. If X was a 5, so basically it's anything bigger than 2. And again, we did this the other day, so it's anything bigger than 2. How about the next question? What values of X would make side B greater? Well, side B, we want this to be bigger. If it's 2, if X is 2, they're equal. So it'd have to be anything less than 2. If it was just a 1, 3 times 1, that's less than 6. If these were just 1s, that'd only be 3. If they were zeros, 0, 0, 0, then that would definitely still be less. So it's anything less than 2 would work for that one. All right, so today, guys, we are going to learn another legal move that'll help us compare expressions. So first thing I want you to do is kind of think about a scale, so a balance, like you see in science. Right now, you guys can see these are perfectly equal, right? I want to know, what could you do to this scale to keep it balanced? What are some things that you could do to this scale to keep it balanced? I want you to name as many things as you can. You can type those right in Edpuzzle. So I want you to pause. What could you do so that it stays level, so that these stay exactly level? All right, so I'm hoping you came up with a couple different things. Maybe some of you said, well, what if I took away the star from both sides? They still would both have a heart. That would stay balanced, right? Okay, what if I added in, maybe some of you said, what if you added in a heart to both sides? Would it still stay balanced? Yes. What if you took away, what if you added in another star to both sides? Would it still stay balanced? Or if you added in 2 stars to both sides, it would still stay balanced. So as long as you do the exact same thing to both sides, so this is super important, you have to do the same exact thing to both sides, it'll stay balanced. You could add things in, you could take things out. Okay, it would definitely stay balanced. All right, so here's a little challenge for you. I have a picture of a scale, and right now I'm telling you it's balanced. So it's level. I want to know, could you figure out what x equals so that this scale stays balanced? So it's kind of tricky here. So obviously there's nothing over here. It's kind of like a big 0. Could you figure out what x needs to be so that this side over here equals 0 too, or it's exactly the same? And how could you do that? So I'll give you a second to think about that. All right, so I'm going to be showing you a couple different things. A lot of you guys probably came up with it already. But here's a question for you. What if I would have added in, would this be okay? If I took 2 1 tiles and put it on both sides, would it still stay balanced? Did I do the same thing to both sides? Yeah, I did. Okay, so I added in the exact same thing to both sides, so it still stays balanced. Now I want to see if you notice what happens. What happens here? Well, those are going to make 0 pairs. So now let's see what I have left. I see 2 x's, and those equal to 2 on this side, right? There's 2 over here. So I want to know, what would x need to be worth if this side's 2 and that side has 2 x's? Well, each x would need to be worth 1. So x would need to equal 1, no matter how you got it. All right, here's another one. Can you figure out, I'm going to tell you right now, these scale is perfectly level. So this side and this side are equal. That's why I have that big equal sign in there. Could you figure out what x needs to be worth so that these 2 scales are balanced? So I want you to pause and try to figure it out. All right, so we had talked about already that you could add things into each side of the scale, or you can take things away. Okay, so here's a question for you guys. What if I would have added, and you guys will see kind of why this works later, what if I added 4 positive ones to this side? Now to keep it balanced, I'm going to do that to this side. Okay, just keeping it balanced. Okay, now let's see what kind of happens on the one side over here. Okay, on this first side, well, these are going to make 0 pairs now. That's all gone. So now I just have an x right here. Just have an x. On this side, I have a negative x and 4 1s. Okay, those are not the same, an x and a negative x. So now here's what I'm going to kind of think in my head. What if I added a positive x to both sides? Okay, what if I added positive x here, a positive x over here? And that's okay because I'm doing it to both sides. That's as long as you do it to both sides. Now look here. That's going to make a 0 pair. Those are gone. So on the first side of my scale, I have 2x is equal to, over here, I have 4 1s. So what would x need to be to make those 2 sides equal? Well, 2 times what is 4? Well, 2 times 2, so each x tile would need to be worth 2. And if I think of that, that would be worth a 2, that would be worth a 2. Okay, now let's go back to our original problem and see if that works. If we said each x tile is worth 2. Okay, so that's a 2. These are all negative 1s. So that would be 2 plus negative 4. That equals negative 2, right? Now this is an x tile, so it's a negative x tile. So if x is 2, I'm going to put in, that's negative 2. So both of those sides would be equivalent. All right, so one way to compare mats, when we're going back to our algebra tile mat, one way to compare to see which side is bigger is if you can get all of the x tiles on one mat and all of the 1 tiles on the other side. So that's going to be super helpful. So our goal today is going to be to get all of the x tiles on one side, doesn't matter which mat, and all of the 1 tiles on the other side. So I'm going to show you a way that you can do it, and this is the third legal move. So what you can do is you can add in or take away anything you want as long as you do it to both sides. So over here, my goal on mat A is to get just x tiles over there. So I need to try to get rid of these 6 negative tiles. Well, to do that, I can add in 6 positive tiles. So if I add in 6 positives, 2, 3, 4, 5, 6. If I do that on that side, I also need to do it to mat B. So 1, 2, 3, 4, 5, 10. These are little squares, 6. All right, let's watch what happens. Well, these are going to make a 0 pair. So now let's look what I have left. I have an x tile on this side and 6 1s on this side. Okay, now it's still hard to tell which side is bigger, but I can tell, I can say, well, if x is 6, they're equal, right? Then both sides would be equal if x was 6. If x was worth 7, then this side is bigger than this side because that's only a 6. If x was only worth 5, then mat B would be bigger. So it's much easier to tell which side is bigger if you get the x tiles on one side and 1 tiles on the other side. Okay, let's take a look at another one. So first thing that I would do if you want to get all the x tiles on one side and the 1 tiles on the other side, you still want to make 0 pairs if you can. So over here I see a 0 pair, make a 0 pair there. Okay, so now if I look at this mat, I see there's x tiles here and 1s over here. Since the x tile's over here, I want to try to keep the x tile over here. Okay, so I'm going to try to get rid of these 1 tiles. So I see 1, 2, 3, 4, 5, 6 of those. So I need to add in 6 negative 1 tiles. 3, 4, 5, 6. Now if I do that to one side, I have to do it to the other as well. 2, 3, 4, 5, 6. You got to keep it balanced. All right, now what happens is these over here make a 0 pair. Those are all gone. Over here, I think I can make a few 0 pairs too. There's a 0 pair, and then a 0 pair, and maybe one more 0 pair, as long as I did that correctly. So I am left with, on this side, -2, on this side, an x. Okay, now it's much easier to compare which side is bigger. So if x was -2, they would both be equal, right? Then they would be equal to each other because that side has -2. If x was worth a 5, then mat B would be bigger. If x was a -10, then mat A would be bigger. So that's how we can compare by adding things into both sides. All right, so we have learned a couple legal moves when simplifying expression mats. So our first one was to make 0 pairs. Second one was that we can take away the same tiles from both sides, remove balance sets. The third one, and our final legal move, is you can add the same tiles to both sides. So you can add in the same amount or the same tiles to both sides, because it's equivalent. As long as you're adding in the same thing to both sides, the scale or the mats would still stay balanced. All right, so now you're going to kind of practice a couple problems that deal with this, and we will talk more about it tomorrow when I am back. Have a good rest of your day.